Luca, you can start the session right now.
Perfect. So, welcome everyone. My name is Luca Gramaglia. I work in Eurostat, and I will be your trainer for the next 3 hours, more or less, talking about Sdmx. Before we start, I'm going to give a few general messages about how we intend to run the session and how it's going to work and what we're going to cover. So first of all, we're going to have two presentations today. We're going to have, first of all, a presentation on the different kinds of architectures that can be used to implement data exchange with Sdmx, and actually to implement also other use cases. And that's going to be the first presentation of the day. And then the second presentation of the day is about a demo of a specific tool, the Sdmx converter, which is one of the easier, let's say, entry-level tools for Sdmx. The presentations from today build upon what you saw yesterday, for those of you that participated in the capacity building yesterday. But I will try during the course of the presentation to refresh your memory a bit about what you saw yesterday, so that even if you missed some parts yesterday or something was not fully clear to you, you can still follow. You will see that you have in the Zoom meeting, you have the possibility to ask questions via Q&A button. And I would like to invite you, if you have questions, to put them in the Q&A box, and then we will be able to easily track them and to answer them. In terms of questions, during my presentation, I will pause at regular intervals in order to take your questions and to answer them. I am also accompanied, however, today by my colleague Abdullah from UNSD, who was your trainer yesterday, who is going to help me a bit manage and moderate the questions. That means that he's going to draw my attention to the most important questions. And if there are some questions which I cannot get to, or for which he can provide an immediate answer in written format, he will be able to do that. Abdullah, do you want to say a couple of words to introduce yourself?
Thank you, Luca. Good morning, good afternoon, good evening, everyone. So if you missed yesterday's session, my name is Abdullah Ghazalov. I'm a statistician at the United Nations Statistics Division, and I've spent the better part of the last 12 years implementing Sdmx and building capacity in the countries. So once again, to reinforce Luca's point, please put your questions into the Q&A box. This is the place for questions. And again, some of the questions I will answer right away, and some of the questions we will answer during a pause, those that require perhaps a more in-depth answer or discussion. Thank you, Luca. Back to you.
Thank you, Abdullah. I also would like to let you know that during the course of the two presentations, at the end of the two presentations, you will participate in a quiz, in an online quiz. We're going to give you the instructions on how to do that when we get there. But this is just to let you know that, yeah, you should pay attention or you're not going to do too well on the quiz in the end. So I think we covered the main things. By the way, you may have noticed that this is the English-speaking session. I do not speak Spanish, nor do I intend to try today. So if by any chance you're in the wrong session and you want to go to the Spanish-speaking session, then in your invitation you should have received the link to that session, which occurs in parallel and is held by my colleagues Edgardo and Fernando. Okay. So I think that without further ado, we can start. Just bear with me a second as I share my presentation. Okay, Abdullah, can you confirm that my presentation is visible on the screen?
Yes, it's on the screen, all fine.
During the first part of today, we are going to talk about the IT architectures and the IT tools that can be used to implement Sdmx. So over the course of the day, of yesterday's sessions, you learned a bit what Sdmx is and what the main components of Sdmx are. And one thing that you definitely learned is that Sdmx is a standard that is supposed to help you establish and industrialize your data exchange and even your data dissemination activities. And you learned about how to model data in Sdmx mostly. And today we're going to see a bit more in detail how you can put this in practice, depending on your use case, depending on what you want to accomplish with Sdmx, what kind of tools you may want to look at, and what kind of tools are actually available to solve your use case and to solve your needs. So during the course of the presentation, I'm going to first start doing a bit of a refresher about how what you saw yesterday, just a few slides. Then we're going to see different use cases for Sdmx and the different architectures and kinds of tools that support them. We're going to see also some specific implementation use cases, I would say. And finally, we're going to have a little quiz at the end. And after each section, I will probably stop and take a few questions if there are any. Okay. So before I start with the actual presentation on the architectures for Sdmx, I just want to give you a short reminder of what you saw and learned yesterday about what Sdmx is, because it's going to be useful to better understand the different architectures and the different use cases that we're going to explore during the course of this presentation. So let's take an analogy. Let's start talking not about Sdmx and data, but let's talk about oranges. Let's say that you are a producer of oranges. So you're a farmer and you have a bunch of oranges that you want to ship to someone, or that you're a manufacturer. I don't know, you make orange jam or you make orange-based products, right? And you want to get together and to understand how you're gonna actually exchange and send or receive these oranges from your counterpart. And it is in this context that it may be very useful to have some standards to rely upon. So why am I talking about oranges? I mean, obviously in the end, I'm going to talk about Sdmx. I'm not really an expert in the orange industry or the orange industrial complex. So, because in the end, you will see that whether we're talking about oranges or whether we're talking about data, the process of trying to get together and agree on how to exchange data and the different methods that we have available to exchange data or to exchange oranges are pretty much the same. So let's say you are a producer. You are an orange farmer, you have a bunch of orange trees that make very beautiful oranges. And you want to get these oranges to a manufacturer. And once again, the manufacturer is the person who collects the oranges and makes something else out of them. Orange juice, orange jam, whatever your heart desires. Well, probably in order to have an agreement on what kind of oranges you're going to need to send and when and how, you're going to have to sign a contract specifying how many oranges and what kind of oranges you're going to send and how and by when. And this contract, besides, it's going to contain something about scheduling, for example, who is supposed to provide oranges to whom, but it's also going to contain some specifications about the oranges, right? It's going to say, well, I need oranges, I need them in a certain type of box. I expect to have a certain number of oranges in each box. The oranges should be of a certain size, not too big, not too small, in order to have a nice standardized process. And pretty much with, when we're talking about data exchange, and when we're talking about Sdmx, we are doing the same thing. Obviously, the producer in the data exchange context is not producing oranges. It's a data producer, which might be, depending on where you're working, it might be whoever your data providers are. So if you're working for an international organization, it might be a national organization. If you're working for a national organization, it might be a regional organization or other data partners. The manufacturer here is whoever the receiver is, which once again depends a bit on where you are placed. If you're working for a national organization, you're often sending data to international organizations or to other organizations within your country. The specifications. Now, what are these in Sdmx? You saw it yesterday. It's really the main object in Sdmx that really tells you what the data look like and what they're supposed to look like. And the main object in Sdmx that tells you this is the DSD, the data structure definition. I'm not going to go into the details in which Abdullah went today about what a DSD is and how many things there are inside and the different roles, but the DSD provides the specifications for what the data that the producer sends to the manufacturer should look like. And the contract, and this is going to be something that is going to be important to just mention for at least one of the use cases. In Sdmx, you have also a version of a contract. It's called the data provision agreement. So you can basically say via data provision agreement, well, this organization is supposed to provide me this data at this kind of time according to these specifications, to this DSD. So whether you're talking about oranges or about data, the difficulties or the challenges are the same. And in Sdmx, we have a way to express specifications, which is a DSD, a data structure definition, and we have a way to express a contract, which is a data provision agreement. Just one final thing before we go on and really talk about architectures and about Sdmx and data exchange, and we stop talking about oranges a bit. All of this information about the specifications, that means the DSD, what kind of structure the data must have, and the contract, the data provision agreement, so who is supposed to provide data to whom, should be stored in a place where it's publicly accessible, both parties can see it, both parties involved in the exchange can see it and can make sure that I can check it at any point in time. In our example with the oranges, it could be a company office. In the Sdmx world, this is an Sdmx registry, which is a central place where all of these artifacts are, all of these objects are stored, and they can be consulted by all the parties involved in data exchange. And once again, it's just useful to keep this analogy in mind as we go through the different scenarios for data exchange. And we see a bit how we can actually get those oranges from the producer to the manufacturer and what kind of tools we can use to do that. Okay. So this is pretty much the first just an introduction that will help us go through the presentation with these analogies with oranges. Short pause here. I hope everything is more or less clear for the oranges and this doesn't confuse you too much. So, I mean, if you have any questions or completely lost, please type something in the Q&A and we'll get to it. But it seems to me that in the Q&A for the time being, we don't have any questions. So I assume that the analogy between oranges and data is pretty much clear to everyone. So how do we actually get to exchange these oranges or this data in Sdmx? Well, when it comes to the exchange of data, to the provision of data, there are basically two different scenarios that can be envisaged. There is a push mode, which is basically the case in which the consumer sends the data to the producer, which the provider sends the data to the the producer sends the data to the manufacturer. So the data provider sends the data to the data receiver. That's the push mode. The action is on the side of the data provider, of the producer to send out the data. And then there is the pull mode, where instead it's the manufacturer or the data receiver that issues a request to the producer or the data provider and pulls the data from the data provider. And these are two different architectures, two basic architectures by which data can be exchanged. And both of these architectures are supported by a standard like Sdmx. But, and this is the important part, the architecture and the kind of tooling that you will need to implement if you're going for the push mode or for the pull mode is very different. It's really very different. So before you think about tools, you really need to think about the kind of use case that you have for data exchange. So let's go to look at the first one, the push mode. What happens with the push mode? Well, in the push mode, as mentioned, it's the data provider, the producer of the oranges, that sends the data to the manufacturer, to the data consumer, using the specifications. So what does this actually mean? So the producer gets the specifications from the registry, gets the DSD from the registry, prepares the data according to the DSD, and then sends it out to the data receiver. And there can be different approaches to this. There can be a more industrialized approach to do this and a less industrialized approach. So we're going to start to look at the easiest approach, the less industrialized approach, the lightweight approach to have a push mode. Here, for example, yeah, it's the analogy with the oranges that you're trying to fill in your boxes and send them out using a wheelbarrow, which is a safe approach, but it's probably a bit cumbersome if you have to do it several times. So let's see how this looks like in Sdmx. So the easiest way, the most lightweight approach to implement a push architecture, where you as a data provider are sending out data to a data receiver according to the Sdmx standard, foresees the usage of a format converter. What is happening here? You have your own data in your own database. You extract the data in some sort of format, and you end up with a file that is not an Sdmx file. It could be a CSV file, it could be an Excel file, it could be a fixed length record file, it could be something else. And then you convert that file into an Sdmx compliant format using always the DSD as the main reference, right? The DSD specifies what the defines what the specifications for the Sdmx file are, what codes are supposed to be used, what dimensions, what concepts, what attributes. So the DSD is always an input for this conversion. And this is the most likely approach and the approach that most newcomers to Sdmx first take when they want to try out Sdmx, when they want to take their first steps in Sdmx. So it's really about, okay, I extract my data in a non-Sdmx format, and using the DSD, and a format converter, I turn it into an Sdmx compliant file. This building block here, which I call format converter, is just that. It's a building block. It's not a specific tool that I'm trying to highlight here. It's a family of tools that can allow the transformation from non-Sdmx formats, which could be, as I mentioned, CSV, Excel, fixed length records, to standard Sdmx formats like Sdmxml or Sdmx CSV. There are many tools that do this in the Sdmx community. Most of these tools have both a graphical user interface and a command line interface. So you can either use it manually via the GUI, via the graphical user interface, or you can automate the process via a command line interface. But in general, all of these tools do this, right? They take a format as input, they transform it in an Sdmx format, and they're usually the easiest entry point to start implementing Sdmx and to start exchanging data using Sdmx in a push approach. What are some concrete examples of this family of tools? Well, here in this slide, I listed some of the tools available that perform these format conversions. These tools are all available for download. You can, at the end of the presentation, I'm going to show you a bit where you can find information about all the different tools that are available, so that you can find your way to the different tools that will be listed here. But examples of format converters are the Sdmx converter by Eurostat, the Excel to CSV converter by eStat, the Fusion transformer by Metadata Technologies, and the Smart package by the ILO. And actually, after this presentation, which focuses on architecture, we're going to look at a demo, look at a concrete example of one of these converters, the Sdmx converter, the one on the top here that is made by Eurostat. So you want to do if you want to do a push approach and you want to do it in a lightweight fashion without investing too much, but probably also without being too efficient, the format converters are the way to go. And as I mentioned, it's usually the first entry point. When you start using Sdmx, you're usually starting to do it because you have to send data to someone in Sdmx. And the easiest way, the easiest entry point, the most lightweight way to get in the water is via a format converter. Let's go then to still the push mode. So we saw how to send data, what kind of architecture, what kind of tools we need to send data in push mode, to exchange data in push mode, but in a lightweight fashion, in a fashion that may not be extremely sustainable if you have lots of operations and lots of data exchange using Sdmx. So let's take a look at how we can implement the push mode in a more industrial approach. Here, the analogy with the farmer is that, yes, you're still sending your oranges and putting them into the nice boxes described by the DSD, but instead of doing that and moving the oranges around, putting them in the boxes with a wheelbarrow, you're using whatever this icon is supposed to represent. I guess it's not really a tractor. It's, I don't know the name in English. But okay, it's an agricultural machine that allows for greater efficiency gains compared to the manual wheelbarrow. So how would this look like? What is the equivalent of in Sdmx and in terms of Sdmx architecture and tools of having a tractor or a machine instead of a wheelbarrow to put your oranges into boxes. Well, here, once again, we're still pushing the data. So it's us as data providers that are sending out the data to the data consumer, but we're trying to do it in a more efficient fashion, in a fashion that is more automated. So what we would do here, in this case, the kind of architecture that we would need to put in place, we're not going to rely on getting the data out from our data source, from our native database into some sort of format, legacy format, CSV, fixed length record, Excel, and then convert it via semi-manually with a converter. We're going to try to actually map direct to the data source, the database in which we have the data, to the DSD, and extract the data from it using this mapping. And in order to do this, you need a building block, you need a component, which I call here database mapping suite. There may be better names for it, but there are quite a few products in the Sdmx world that allow you to do just that. They allow you to connect to your data source, to your legacy data source, your legacy database that you have. And by the way, I just want to say to make a short note. Whenever I say legacy, I do not mean that it's bad. Legacy to me actually has a positive connotation. Usually, if a thing exists, it's because it serves a purpose and has served a purpose for a long time. So when I say legacy, don't take it as something something old that needs to be absolutely replaced. No, it's whatever you have in place at the time in which you want to start doing Sdmx. And so don't, I know many people associate a negative connotation to the word legacy, but I don't, and I do not mean it that way. So you have your legacy database, and with these DB mapping suites, you can map the information in your database directly to your DSD. The DSD is still the object giving you the specifications and telling you what your data needs to look like. And the mapping suites also contain components that allow you to extract the information from the legacy, mapping it to the DSD on the fly, let's say. So the advantage of putting in place something like this is that in the end, you don't need to extract your data in a file and then semi-manually convert it via a format converter. No, you have a tool that allows you to do this. You've done this mapping once between the DSD and your legacy data source. And yeah, basically you do the conversion or you do this mapping on demand whenever you do an extraction, right? And the outcome is an Sdmx compliant file that you can directly send to your data consumer. So let me talk a bit more in detail about this component that I introduced, this building block that I introduced, the DB mapping suites. So usually this is a building block that has several interacting components, but at its core, it has components that allow you to connect to a source database and to map their internal structure to the structure defined by the DSD. These mappings are then saved somewhere in a local storage. And then you have a way, usually with a web service client, to extract the data from the source. The data then the data from the source is then automatically converted to the format expected by the DSD using the mappings that have been constructed, and you end up with a nice Sdmx file as the output in the end. And usually these DB mapping suites come with a set of components and graphical user interfaces to manage the mappings that you build between your source legacy database and your DSD. What are, once again, some examples? And these lists are not supposed to be exhaustive. So there are others out there, but the two that I want to mention here is the Sdmx RI. RI stands for Reference Infrastructure Suite. which is a set of components that do exactly what I mentioned. There's a mapping, something called a mapping assistant that allows you to create the mapping between your legacy source and the DSDs. And then you have a web service that communicates with the mapping assistant in the background to interpret those mappings on the fly upon request and output an Sdmx compliant file. But this is not the only one. There's other suites that do the same thing. The data manager, for example, from ESTAT is another one. And actually, on the fourth day, so on Thursday, you're going to see a more detailed presentation on a specific application use case using the data manager. And this presentation will be given by our experts from ESTAT. So these are just some of the alternatives that are available, and it's something that to be investigated, and that could be, these are components that could be useful for you if you're going for a push approach, but in a more industrialized fashion. So far, I've talked about push mode. So push mode, you're always, the data producer is sending the data actively to the data consumer. And we saw two different ways of doing it, which require two different IT architectures: the lightweight approach with the format converters, and the more industrialized approach with the DB mapping suites. But as I mentioned in the beginning, there is another mode that is available for you and that can be supported by Sdmx, which is the pool mode. And what happens in the pool mode? Well, in the pool mode, it's not the data provider telling the sending the data directly to the user, to the consumer, but it's rather the provider says to the consumer, sends a notification to the consumer saying, look, my data are ready. I have new data available for you. I have new oranges, if you want, available for you. And then the data consumer goes and retrieves the data. Or in the case of oranges, the data consumer receives a message and he sends out a truck to go and get the oranges. So in this case, the producer just needs to tell the user, the consumer, my data is ready, my oranges are ready, and then it's the consumer that goes and gets them. And this is what we call the pool mode, because the data is being pulled from the provider by the consumer. How do we sustain this with? And you see that in this interaction, you need to have a way for these notifications to be exchanged, right? You need to have a way for the for the producer to tell the consumer my data are ready, and for the consumer to act on this notification in an automated fashion. So how does this work in terms of an Sdmx architecture? Well, the Sdmx standard offers a very nice, and I think it's one of the main advantages, frankly, of the Sdmx standard, but it offers a very nice mechanism to notify users of new data being available, and to then automatically put in place a pool mechanism. How does that work? Well, a part of the architecture is very similar to what we had before. On the provider side, if we want to put in place something like this, a pool approach, we still need to have our data source, which is mapped to the DSD or DSDs via some sort of DB mapping suite. So from that point of view, things are quite similar to the industrialized push approach. But then there is a new component that becomes available and that becomes very important, which is the Sdmx registry. Once you have a centralized Sdmx registry, which usually is hosted by the consumer, it's usually the consumer that makes it available and not so much the provider, but it could also be another registry that belongs neither to the consumer nor to the provider. In the end, you just need to have an Sdmx registry. You can register in the Sdmx registry different data sources, and you can have consumers subscribe to those data sources. So then whenever there's an update, the provider sends, tells the registry, look, I have some new data. This notification is sent out to the subscribers to that data source. And based on that notification, the consumers can pull the data via web service request to from the provider. So there is a part of the architecture that is very similar to the previous case, but then you have the whole mechanism of registration and subscription, which requires an Sdmx registry to be put in the loop. And yes, and obviously the actual pull is done via web services. And here I introduced therefore a new component here for the pull mode, which is the Sdmx registry, which is a very important component in general for Sdmx implementation. The Sdmx registry is the place where you store Sdmx objects, all your DSDs, all the code lists, all the data flows, all of those nice objects that Abdullah introduced yesterday. They're all stored in an Sdmx registry. The Sdmx registry Sdmx registries also allow users to retrieve these objects via Sdmx web services, and also allow for this registration and subscription mechanism that I mentioned, which is essential to put in place the pull mode. And the vast majority, I would say all softwares that implement an Sdmx registry provide a user interface to create, to search, to download the different Sdmx objects that are stored within it. So the Sdmx registry is really a component where all the different objects are stored and where they can be retrieved, where they can be managed, and where they can be retrieved using standard Sdmx web services. Once again, for this component, in case you're interested in putting in place some of these components, if you're interested in putting in place an Sdmx registry for some of your use cases, there are different software available that do this. Once again, the list is not exhaustive. I'm not making publicity for anything. At any rate, most of these software is available for free, so I don't get a commission in any way. And there's other software definitely available, but I just want to mention the different ones that exist and that are most commonly used. There's the Sdmx registry by Eurostat. There's the Fusion registry by Metadata Technologies, and there's the Meta Manager by ESTAT that fulfill this registry role and allow data to be stored and managed. Sdmx objects to be stored and managed and to be retrieved via standard Sdmx web services. By the way, I just want to mention already here that tomorrow, in the session for tomorrow, we're going to look in more detail at Sdmx web services and how you can retrieve structures and data using the standard web services. So that's something that we're going to see more in detail over the course of the week and specifically tomorrow. Okay, so in the end, if you want to have a pull approach, you need to have your DB mapping suite, but on top of it, you need to have a registry where you have set up this registration and subscription mechanism. Now, there is a slight twist on the pull approach that I would like to touch upon, a slightly different kind of architecture, which is similar to the pull, but is some specific in some way, which is the hub approach. And here, once again, if we think about the oranges, what is the hub? Here, it's a twist on the pull. You can think of it in cases where the request is not coming from the manufacturer, but directly from the final user of the data or of the oranges. So let's say someone wants to order orange juice. They send a request to the manufacturer, who then redirects it immediately in real time, let's say, to the provider, so that the provider can return the data to the final user. And okay, I think we're stretching a bit the orange analogy, But this hub node is something that can be implemented also with Sdmx, and it's something. It's not used in many cases, I must say. We have it in Europe for the census. We have the census hub, which implements this hub approach, and which works as follows. Each NSI, National Statistical Institute, has implemented, so each NSI has implemented Sdmx web services, so has implemented used the DB mapping suite to map their legacy database to the census DSDs that Eurostat has created. And then the final user, the European citizen or citizen of any country of the world, can log on to an application called the Census Hub, issue a query, and then that query is redirected by the hub to the NSI or NSIs that hold the data. The query, then the NSIs, forward the query to the source database via the DB mapping suite software that each NSI has installed. The output is returned in Sdmx format and returned to the user. So in the end, the hub approach is a way to federate. You can really use this word to federate different source databases using Sdmx and make the information available to the user through a single entry point. So it relies here. The hub approach relies on the same architecture, I would say, as the pool mode on the NSI side. At least you still need to have a web service. You still need to have your DB mapping suite. There's no registration and subscription mechanism in the registry, but you definitely need the registry to hold all the DSDs that each NSI has to map to. So it's a bit of a specific use case, but it's something that exists and is new and that is enabled by Sdmx. So I want to emphasize. Okay, I think we can take a pause here, and I can take some questions. I see there are already some questions in the chat, and please feel free to ask other questions. We're going to take a little pause here to ask questions before we go look at use cases for Sdmx that go beyond data exchange. Abdullah, what do you have for me in terms of questions?
Yes, Luca. So we have 3 questions outstanding, and the first one is, as we currently don't have a legacy database and we're designing a new database, are there any instructions or tools to help us store the data in Sdmx compatible format?
Okay, that's a very good question. And Abdullah will ask as well if you have something to complement, to feel free to do so. So, let's say you don't have a legacy database, right? You have something like, you're in this situation. You have a data, but you don't have a legacy, a database yet. In my opinion, if you don't have a database, but for whatever reason you want to implement Sdmx, I don't know if you're looking to implement Sdmx for dissemination, or maybe more for data exchange because someone is asking you to provide data in Sdmx format. I don't think the key here is to necessarily store the data in an Sdmx format. I think the key here is to construct a database that is already aligned with the structure that the Sdmx structure that you want to map it to. So let's say that you want to do this to implement a push mode. You're sending data to some international organization or so another organization, and they told you, look, we want the data according to this DSD, and you don't have a database yet. If you want to build a database, what I would do is not necessarily try to use a specific software or a specific database that is more Sdmx compliant, but simply build my data set based on build my database based on the DSD. So the DSD will tell you, look, I'm expecting 6 concepts, and these concepts are supposed to be coded with these codes. Just build your database already using the DSD as the definition of your database model, of your star schema, basically. And then that means that, yes, you're still going to need to have some sort of software like a DB mapping suite that takes the data out of your database and converts it to SDMXML. But this will be very easy. It will be very simple because you're actually not going to need to have any mapping. The most difficult part or the most annoying part in setting up, in configuring these DB mapping suites is really to map the structure of your legacy database to the structure of the DSD. That's where you spend lots of time. The rest is more technicalities. If you don't have a database and you have the chance to build your database based on the DSD because you know what the DSD structure, your target DSD structure is, don't care too much. I wouldn't obsess too much on the technology. Just make the structure according to the structure foreseen by the DSD. And then the mapping, which is the most annoying part here, will be very simple if needed at all. And it will be quite easy to then end up with an SDMX compliant file in the end. I don't know, Abdullah, if you want to add anything to that based on your own experience.
Yes, just a couple of points. One is all the time we are asked questions, how do we build in the database in an SDMX compatible format? And the issue is that, well, SDMX is designed to be compatible with any format, so to speak. And we have a wide range of tools that Luca has mentioned that support any source format. So in other words, if you have a legacy dataset, what Luca referred to as a legacy database, or it doesn't even have to be a database, it could be an Excel file or a CSV spreadsheet or the output from a production database. It can be mapped to SDMX using any of the tools that are available. So it's not so much, I think, the issue is not so much about compatibility with SDMX as about the mappings and tools that you can use to map legacy formats to SDMX. This is one. The other is, we don't have a database. That could mean that you don't have a dissemination database or that you have no database at all, right? And for a dissemination database, SDMX basically can be the foundation. You can create a native SDMX dissemination database and save yourself time on building quite a bit of infrastructure. If we're talking about a production database, the story is slightly different. But I think that once we have further support from tools such as VTL, then you would be able eventually to use SDMX along practically all, or at least most, of the statistical production chain. And then, yes, then basically you can be SDMX native all the way, so to speak. Back to Luke. I don't know if you would like to further comment on that.
I know, just I think you mentioned an important point. Indeed, in my answer, I was assuming that we're talking definitely about a dissemination database or some database that's supposed to simply hold the data that is supposed to be sent out. If the database is also supposed to transform the data, right? I mean, as Abdullah mentioned, SDMX is very good at describing data. And when it comes to transforming data or describing transformations between data sets, well, there is an additional element of SDMX, which is called VTL. I'm not going to go in detail. That is still not, that exists, but it's still not very well supported. It's supposed to show you or encode transformations between data sets in an SDMX compliant manner. So, and I think that this is what Abdullah was referring to. Indeed, if by database you mean, well, I need a full-fledged production system, I think SDMX is very well placed to describe the end result, for example, or the start of what the structure should look like, not necessarily all the transformations that happen in between for the time being. So indeed, in my answer, I was assuming that we're talking about some sort of dissemination database, which may have not have been the case given the question.
Yep. Thanks, Luca. The next question we have is, there are situations where data is available in Excel or statistical packages. Do these mapping tools support them? And there is a qualification. The question above is more for independent or small-scale users who do not have access to an IT staff and an SI type organization.
So if your data is available in Excel, yes. So the format converters, at least depends a bit then on the specific software, but many of the format converter tools support conversion from Excel to a specific to an Sdmx compliant format. Usually each converter tool wants the Excel to look a certain way. It supports a certain style of Excel or expects the data to be arranged in a certain way. But definitely the format converter tools, at least some of them provide this. And actually, in the next presentation after this one, when we look at the converter and we look at the demo of the converter, I'm going to show you how the Eurostat Sdmx converter can be used to convert Excel into an Sdmx compliant format. So definitely in terms of a format converter, this is supported. When you're talking about statistical packages, I'm not sure exactly, maybe you're talking about, I don't know, have data in R, in an R data frame. I mean, usually what you would do is, or it's not clear exactly if you have this in mind, but I mean, once again, either you would output this information in a CSV format, for example, and then definitely most of the format converter tools support the conversion from CSV, or you could push the information from your statistical package to a database, and then there you can either extract it as a CSV from the database or map it from the database. In general, I would say that if you don't really have a proper database, but you have just data in Excel or in different kinds of file format, you're kind of restricted here at what you can do. I think anything that looks like the industrialized push mode or the pool mode does require you to have some sort of a database. If you're just talking about files, then you're kind of restricted, I think, to the lightweight approach. But the lightweight approach with the format conversion tools still allows to support different formats and definitely Excel as well. But once again, the exact way it's supported depends on the tool. Not all tools expect the Excel to look the same way. And we will see a specific example later on today.
If I may add, Luca,
please.
I mean, the straight answer to the question, do these mapping tools support Excel or statistical packages? I mean, the simple answer is yes. In the case of Excel, you can immediately, well, or at least most of the time, depending on how complex your Excel file is, but generally you can take an Excel file and map it using Sdmx Converter or ILO Smart or other tools and convert it to Sdmx. In the case of statistical packages, you might have to export the data into CSV first, but then again, you can transform it to Sdmx. The point here is that you can adapt Sdmx reporting and dissemination to a variety of situations and environments. If you have nothing, no database, no statistical package, nothing at all except Excel files, you can still use Sdmx. If you have a full-blown data warehouse, you can still use Sdmx. It's just that if you have more advanced infrastructure, you can use Sdmx reporting and dissemination more efficiently. But even in the simplest situation, you can still use Sdmx and you can still reap the benefits of it. And then we move on to the next question. I think the fourth arrow should point to the factory. Is that correct? I'm not sure which slide this applies.
Maybe in the pool mode, maybe in the hub mode. I must say as well, if it's about the hub mode here, yes. I guess to be more precise, but I was mentioning I was stretching a bit the comparison, so I did put a caveat here. But it would be more correct to say that when there is a request in the hub mode, then yeah, you could say that the request goes back from the preparer to the factory, and then from the factory to the requester, kind of. Instead of how I simplified it here to go directly from the provider to the requester. But yeah, I think with the hub mode we are stretching a bit the analogy. I think a better analogy would be if you have a request that requires, for different kinds of oranges, or oranges from different producers, because someone is very particular about the origin of his orange juice or the exact composition. And then the factory sends out requests to several producers to get the data back and then combine it together and send it back to the requester. So I fully accept that the representation of this of the orange analogy for the hub mode may not be very good, but I think we're stretching the analogy. So yeah. But that's a good point. Yes, I tend to agree with what our colleague mentioned regarding this slide.
Yeah, thanks, Luca. Next question. Hi, can we have the presentation?
Yes, all presentations will be made available on the conference website. I believe this will be done next week when the conference actually starts. So here we're in the capacity building before the conference, and I think the decision was taken to make all presentations available, including the conference presentations at the same time. So all the material should become available on the conference website next week.
Yes, and there have been quite a number of questions about video recordings of yesterday's session and today's. Again, these will be made available at the conference website when they're processed and ready. And that should take place in the next 2 days. We have 2 remaining questions, and I think that we can answer those before we move on.
Yeah.
The first, for push mode, are there any software applications available on Sdmx website or in general, which have support or extension for big data, Hive database?
I'm going to need your help with this one, Abdullah. I'm not sure about this one, frankly.
I'm not aware of any software applications that support Sdmx applications that support the Hive database. Generally, Sdmx for big data has, we have been looking into this at the Sdmx working groups and at Sdmx Secretariat, and support for big data will improve going forward. In Sdmx 3.0 in particular and others, but at this time it's at the experimental stage. Specifically regarding the Hive database, I'm not aware of tools that support that. So you may have to sort of resort to a few tricks and perhaps aggregating the data before it can be used with Sdmx. Okay, and then we have the final question for this session. Is mapping assistance in mapping assistant tool, can we map multiple concepts for different statistical domains? If yes, then how to send specific data in production mode?
Okay, I think I'm going to make a bit of interpretation to be able to answer this question. So in the mapping assistant, you can definitely use the mapping assistance for different DSDs covering different domains. Okay, so if you have a DSD that is available for one domain on national accounts and another DSD that is available for balance of payments, then you can definitely use it for multiple domains. The way this is defined is that actually when you actually request the data, so you have to kind of remember how the data is actually modeled in Sdmx. You have a DSD that describes the data in a given domain. And actually, in a given domain, you may have multiple DSDs that define the data structure. And then for each DSD, you have the data flow that describes what the actual flow of data, so what is actually being exchanged. So the data flow, what is actually exchanged is described by a data structure, a DSD, and each data flow has a DSD, but one DSD can have several data flows. So usually, in case you would have different domains, you would have different DSDs and different data flows. In which case, when you actually request the data to be extracted from the mapping assistant, the request is always made for a specific data flow. And then the mapping assistant knows, okay, well, I'm getting the request for this specific data flow, which is linked to this DSD, which has these mappings to these tables in the database, and then I can extract the information that I need. So the request of data is usually done always for a specific data flow, which is tied to a specific DSD, which has specific mappings. And this allows you to have mappings for multiple domains with the same tool without a risk of not knowing how to, what you need to extract or how to extract it. I'm not sure if I'm trying to interpret a bit your question. And on this, I would like to also emphasize on the fourth day, you will see a specific example of how this architecture is implemented using the ESTAT set of tools. And that's something that I think, okay, it uses the specific ESTAT set of tools, but the logic will be the same also for other tools as well. I think during that presentation, the process of how you do the mapping and how you make information available to different data flows will become a bit clearer. I'm not sure, Abdullah, if you have more to complement or if you have the different interpretation of the question than I did.
Yeah, just a couple of comments. When you map data using whether it's Mapping Assistant or Sdmx Converter or other software, the unit of mapping on the Sdmx side is the data structure. So you look at your data, at your source data, and then you take a data structure definition and you map your data to it. So it's not so much about mapping multiple concepts as about mapping to multiple DSDs perhaps. And there, the Mapping Assistant is incredibly flexible. The question was asked also yesterday, just to repeat, you can take the same database and map it to multiple DSDs. With a few simple SQL queries, you can take multiple databases and map it to the same data structure definition, create a data set out of multiple databases if necessary. You can create multiple data flows over the same database or over multiple databases. So the Mapping Assistant does it very well. It helps you establish a single endpoint, a single web service over all of your data. And this all can be done, and it's not even rocket science. It's relatively easy to do. The trick here is not so much the setting up the infrastructure as the actual mapping of your data to Sdmx data structures. That can be tricky, especially in the case of global DSDs, because the global DSDs, they are designed for the world. They are the common denominator for the world, and they implement a certain logic. You can always map your data to the DSD, but sometimes, especially in the case of complex global DSDs, it can be a little bit tricky. But this you would have regardless of which technology you use, whether it's Sdmx, whether it's a bilateral contract, whatever it is, you would still have that issue. Thanks, Luca, back to you.
Okay, I think we don't have any more questions, so I will continue the presentation. We covered here so far the different architectures and different styles of tooling that are needed for different types of data exchange configuration. And indeed, the focus of Sdmx since the beginning has been data exchange. So this is called data, Sdmx stands for physical data metadata exchange is at the heart of it. But Sdmx can also support use cases that are that go beyond data exchange. And for these use cases as well, I want to show you a bit how you can support them and what kind of tooling is necessary. The main use case that is a bit beyond data exchange that is supported by Sdmx is data dissemination. Now here I'm really stretching the analogy with the oranges. You can think about the, I mean, I guess you know more or less you all know what data dissemination is. It's basically when your data is made available to anonymous consumers, right? So it's a bit, in the case of the oranges, it's a bit when your oranges or your orange juice is being sold at a retailer, right? You don't really know who is consuming the oranges. You are not in direct contact with the customer. It's an anonymous customer to you. But data dissemination is a very common use case right now for the use of Sdmx. So and Sdmx, the Sdmx standard can be used and is used as a basis for setting up a public dissemination infrastructure. And this is something that's implemented, for example, here in Eurostat or in EStat or in many other organizations. And the overall architecture that is needed is very similar to the one that you use for the pool mechanism or for the hub. So the DB mapping suite is something that is still needed for dissemination. But there are two additional elements that you would need to implement as well in case you want to use Sdmx for data dissemination. First of all, you do need an Sdmx registry. But the thing is that if you're doing dissemination, you are the one creating the DSDs. So whereas for data exchange, often it's your partner, your consumer that will tell you, look, I need data according to this DSD. And yes, you may need to interact with the registry to retrieve the DSD, but you're not the one creating it or managing it. If you're doing Sdmx for dissemination, it's your own data. You are the one who has to create the DSDs. So the Sdmx registry really becomes a very important component to be able to create the DSDs and manage them. And then something that you will need to have as well to be able to have data dissemination is that having a web service is not enough. Your users probably will not be satisfied with just having a web service. You are going to need to offer some sort of visualization tool so that the users can browse the data and view the data in a more user-friendly fashion. So these are the basic components that you will need. You will still need your DB mapping suite to be able to retrieve the data from your dissemination database, map it to the DSD to the extent that the mapping is actually needed. In many cases, if you're doing a full Sdmx-based dissemination, your database structure is based on a DSD, so there's very little mapping needed. But you're going to need to manage your own DSDs, to manage your own registry, to create the DSDs and the code list and everything that is needed for this. And you're going to need to have some sort of visualization tool for to allow your final users, your anonymous users, to view the data in a suitable way, in a way that is user-friendly. And another use case that I want to touch upon is what I call Sdmx for data science. And here, it's a use case that becomes more interesting and more important as more organizations are adopting Sdmx. One thing that is very interesting is that once several organizations disseminate data using Sdmx, then they're all exposing their data using the Sdmx web services. They're all exposing their data using the same syntax, Sdmx syntax for web services, which then is quite useful for someone who is an analyst or a researcher, because he can retrieve data from different sources using always the same kind of web service configuration without having to investigate for each data source how exactly to retrieve data and what are the parameters available. No, the standard Sdmx web service specifications tell you basically what what is the syntax to retrieve data from an Sdmx web service. And so we have seen over the course of the past few years an increase in the number of tools that that are available to connect to to Sdmx web services with different statistical software. So here we have a lot of connectors that I represented here that are able to connect to Sdmx registries and Sdmx data services and retrieve the information and represented in whatever internal structure is using the software to represent data. So these are two interesting use cases that go beyond, let's say, data exchange. For both of them, the additional component, the additional building block that you need is some sort of visualization analysis tools that allow you, that connect to an Sdmx web service and that allow you to visualize the data or to import it in the statistical software, statistical packages that you use for data analysis and for data visualizations. And indeed, we have quite a lot of different components that are available, both to view data that connect to an Sdmx web service and allow you to view it and to browse it, and that allow you to connect to an Sdmx web service and import the data into your favorite statistical software. In the next slide, I'll just show a bit the kind of connectors and the kind of data browsers and viewers that are available. In terms of data browsers and viewers, these also often come as part of these DB mapping suites. DB mapping suites often also include some sort of data browser, a client that allows you to connect to an Sdmx web service and view the data. So you have here a data browser that comes from Eurostat, which is part of the Sdmx reference infrastructure. You have eStat that also has a specific data browser. And in the .stat suite, the Data Explorer does a very similar function. In terms of connectors to take data, connect to an Sdmx web service and ingest the data in statistical packages, there's quite a few of them, and the number of such connectors has been increasing. So there's a couple of connectors for Excel to just connect to an Sdmx web service and extract the data in Excel. There are several connectors for R, which is a very widely used software, obviously, in statistics. There is a very nice connector for Python. There are connectors for Java, MATLAB, SAS, and a very new connector as well for Power BI, which, as you may know, is a specific business intelligence tool by Microsoft, I believe, is the owner. Yeah, and actually, once again, tomorrow we're going to look a bit more in detail at how you can use web service in Sdmx to retrieve structures and retrieve data if you're interested in this use case. Then I'm not going to do a pause here. I will just show you a bit, give you a list of foretaste of what you will see, especially on the fourth day. Some examples of what a concrete architecture looks like. So I tried to give you here a high-level overview of the different building blocks that you will need, depending on the use case that you're trying to address. But then each building block has different software that can realize it, that can implement it. And whenever you make a choice, we'll see that the concrete architecture will vary. So I just have some slides here, and once again, on the fourth day, you will see step by step how you can implement one such concrete architecture. This is, for example, the Sdmxri architecture. So as I mentioned, the Sdmxri is a suite of components that do many of the things and cover many of the building blocks that I mentioned today. It covers DB mapping via the mapping assistant. It offers a web service. It offers also a data browser. And if you go for the Sdmxri architecture, this is pretty much what your architecture will look like. You will have a mapping assistant that connects to a legacy database, maps it to the DSD, stores the mapping in a mapping store, and then you will have the test client and SI web service that are able to connect to the legacy database and the mapping store to send out, to create Sdmx data. And you will have also a data browser to visualize the data in a more user-friendly way. Another, oops, sorry, I should have used this one before. Another option is to implement a solution with an SDMX-based data dissemination or reporting platform. And there are different options that are available now that are kind of a full package. And I just want to mention here the .stat infrastructure. The Fusion registry also can allow you to have an out-of-the-box data dissemination or reporting platform. The eStat kit is in many ways similar to the Sdmx to the reference infrastructure by Eurostat. Actually reuses some of the components and has different components to take care of different building blocks. And one thing that I also wanted to highlight is, sorry, in case you do not like any of the available components that are available off the shelf, or you think you can do better, which is absolutely possible, there is a library called Sdmx source, which allows you to quite quickly create your own Sdmx system. So it's the Sdmx source library allows developers to quite quickly use the basic functions there to build up a custom Sdmx system. So if you don't like any of the options available, you still have, and you want to develop something new, you still have a set of libraries available for your developers to get started, let's say. So you don't need to get started from scratch, and you have a good basis to build whatever custom solution you want. That's pretty much it. This is another architecture actually from the ILO, the way it kind of works on their side, where they have very different data sources. They use format converter tools to put them all in a dissemination data warehouse, where then the data is made available to different dissemination and data analysis software. So here it's a dissemination use case, I would say, or a data warehousing use case, where the data is fed into the warehouse using a conversion process. So that's another kind of architecture which is implemented in the ILO, which mixes and matches a bit the different styles that we have seen during the course of the presentation. Anyway, I think we're pretty much coming to the end here. I just want to summarize the key messages before we go on to the quiz, to make sure that you paid attention. What are the key messages that I would like you to take away from this presentation? That the Sdmx standard is a standard that can support different styles of data exchange and can also support dissemination. Depending on your use case and the style of data exchange that you want to go for, you will have different IT architectures that you will need to implement. And the specific capabilities, the specific components, building blocks that you will need depend on the specific use case and that you are interested in. But for each of the building blocks that are required to support data exchange in whatever configuration, there are already tools available, specific software components for you to look at, and the vast majority of them are open source and free for use. So once you go back home and you said, oh, I want to implement Sdmx, think about your use case, think about using this presentation also, what is the best IT architecture, different components that you need to support your use case, then investigate what kind of software tools are already available to fulfill to implement the components that you need. and choose the best one. All right, that's pretty much it. I have a short quiz for you with a few questions, but I see that there are a few questions here already. So let's go through the questions before, and then we can go to the quiz, I would say.
Yep, thanks, Luca. So question 1, I think that we can take the questions currently outstanding and then go for the quiz. Question 1, in our organization, the data is still in silos with separate technologies. Does the Sdmx mapping suites, must Sdmx mapping suites be installed one by one for each database or just one for all organization?
No, in general, okay, I cannot speak for all possible mapping suites, but in general, a single installation by organization should be sufficient as long as the data sources can be accessed from wherever in your network you place the application. It should be sufficient to have one application that can connect to several databases. It may depend a bit on the specific software, but I think most support this this architecture. I'm not sure, Abdullah, if you have anything to complement to this.
Yeah, just very quickly, I mean, it's not unusual to have data scattered across multiple databases or data sources. You can have multiple scenarios here. If you have several dissemination databases or several source databases that need to be connected to and exposed through a web service, then yes, you only need one installation. If you have data in a variety of sources, relational databases and non-relational databases and Excel and CSV, you still need one source. You can still, you still need one. You can still expose them through one mapping suite using, one web service, but there you would need to put in a bit more effort to bring the data together. You might create databases and load the data into, from Excel or CSV or non-relational sources into that database, which again is possible using tools such as Istat Data and Meta Manager. So depending on the situation, it can be more complex or less complex, but you can still expose all of your data through a single web service. Back to you, Luca. Oh, actually, let's move on to the next question. Do you know some connectors for Microsoft.NET?
I have a bit of a hard time understanding the question, I must say. So, because there are definitely different tools that run on .NET. I believe the best example would be the .stat platform by the OECD, if I'm not mistaken. But when you talk about a connector for Microsoft.NET, so when you look at connector, I think of something like, okay, I connect to a web service and I can play around with the data, and .NET is more like a development framework. I'm a bit confused by the question. I'm not sure, Abdullah, if you have a better interpretation of it.
Well, perhaps what is important to mention here is that the main Sdmx library, Sdmx source, it is available in Microsoft.NET. So yes, you can use it, you can load Sdmx objects, you can transform, all of this is automated. You don't have to your manual code, for example, to load a DSD or to transform it. So in that sense, yes, it's not just a connector, it's a whole library that you can use to very quickly build your applications.
Maybe it was just a misunderstanding, because when, at least in the context of this presentation, I use connectors really for, statistical software that just retrieves the data. But indeed, Sdmx source is in .NET, so you can then use the Sdmx source library to build whatever you want in .NET, basically.
Okay, next question actually is not one, it's two questions. First, is it correct to assume that a registry does not house the data, just the DSD and web services? Great question, Luca.
Yeah, so that's a very good question. So the registry indeed is not about housing data. It's about housing the structural metadata, so the Sdmx objects, which is the DSDs, the data flows, the code lists, the MSDs, the constraints, all the nice objects that Abdullah introduced yesterday. That's what the registry is mostly for. And it exposes these objects also via web services. So you can query via Sdmx web services, you can query a DSD, you can query a data flow, you can query a code list, you can query a concept scheme. The registry also plays another role in terms of data registrations. So I mentioned this when we talk about the pool use case. You can register data sources in a registry, which means basically that in the registry you say, well, okay, for this data provider, I'm going to get the data from this data source, and this should be an Sdmx data source with available via Sdmx web services. But in this case, the registry does not actually store the data itself. It just stores the information about the source and where the data can be retrieved. So indeed, in terms of storage, the registry is really about the structural metadata, and it can contain information on the data sources, but not the data itself. And then there is a second part of the question I see.
Yes, how does the data science use case allow visualization of data?
Okay, well, here it really depends on the kind of software that you use for data science. You know, here in Eurostat we use R quite a lot, for example, and R has a lot of libraries for data visualization. So what our users do, myself included, is if we need to do a fancy visualization based on data, we import the data in R using the relevant connector, and then we use the R libraries for visualization, right? So usually all of this software, all of these Cisco packages have their own libraries for visualization or have their own ways of visualizing data. And so the idea with these connectors is that the connectors themselves do not provide usually visualization functionalities. They just provide you with a way to easily connect to an Sdmx data source, and then you can use the already existing visualization functionalities in that in the Cisco package to view the data. I will actually show tomorrow when we talk about the Sdmx web services. I will quickly show a use case that we implemented where we did just that. Right, we had several data sources exposing data using Sdmx web services, and we really built in a matter of a few hours a web application using R to visualize the data. So it's not the connectors themselves that provide the visualization opportunities. Once you get the data in your Cisco software, you usually have visualization libraries in there that you can leverage.
Yep, thanks, Luca. Next, we have not a question, but a comment from Jonathan Challoner of OECD. I would advise organizations against building their own software at a great cost. Many tools exist that cover all steps of the data lifecycle, and a large number of them are open source. Check the list on sdmx.org and look at contributing to the projects such as .stat suite open source rather than build your own. Okay, you made it's a comment, not a question. I think that, Luca, you made the point also in your presentation. Yeah. I would say this. Yes, there are a lot of tools available, and yes, it's usually make far more sense to use those tools than develop your own. However, if you must develop your own tools, one reason could be, for example, language, or another could be security issues, then please use Sdmx source. That is a must, as use the library instead of trying to build your own system from the scratch, because building your own system from the scratch is not going to work well, for sure.
Yeah, but I absolutely agree with Jonathan's comment in general. I mean, try to reuse first and only try to develop something new.
Yep. Absolutely. Then we have a question. Are there many that you know in-house built SDMX? What integration challenges in terms of in-house built SDMX for some of the more standard applications available? I think we've just talked about that.
Yeah.
Don't build in-house unless you absolutely have to, but if you do have to, then please use the library Sdmx source.
Yeah. I mean, in general, you know, if you really must build in-house, as long as you respect the standard and you your input or your output is standard SDMX format, standard SDMX objects, or then the interoperability of other components should be okay. But once again, before thinking about developing your own, really look at whether it's really needed. Yeah.
We are running slightly behind time, but the next question is quite interesting. Can this practice be applied for both aggregate and microdata?
Okay. So that's a very good question. And I think, Abdullah, you can, we could both contribute and together write several papers on this. But I think at least historically, SDMX was really more meant for aggregate data. And you can see this in the model. The model for SDMX that Abdullah so eloquently introduced yesterday is really thought of for aggregate data first, I would say. And it can be used for microdata, but it's sometimes a tough fit. This will change with Sdmx 3.0. Sdmx 3.0 has some changes to the model that will make it much easier to apply also in the case of microdata. You can already do that, but it requires a bit stretching of the semantics of the model, I would say. And with Sdmx 3.0, this will not be the case anymore. So I would say that in general, SDMX currently, in terms of modeling, in terms of infrastructure, in terms of services as well, is more thought of for aggregate data. And anyway, when we talk about dissemination, often we're talking about aggregate data, but it can be used for microdata as well, with a bit of twists. And with Sdmx 3.0, those twists should not be needed anymore. I can tell you from our experience, we do use SDMX also to collect microdata and to model the collection of microdata using the Sdmx standard and the Sdmx modeling. I think I wouldn't start with that. Let's start with aggregate data, and then once you get comfortable, you can see how to apply to microdata as well. But this is definitely something where with Sdmx 3.0, the support for microdata and the specificity of microdata will be enlarged.
I would just like to quickly add that aside from Sdmx support for microdata, which will be greatly improved in Sdmx 3.0, and I think will open new horizons. But aside from that, what's also important is to go from microdata to Sdmx. That is to go from microdata to aggregate data, then to Sdmx. And you can do it in different ways. You can use statistical packages, but notably ILO Smart. You can use it to define both, to process a microdata set, define aggregation operations on it, and then map the result to Sdmx. So sort of in one go, using one tool, you can go from, you can export a microdata set into Sdmx. And this is an extremely powerful approach. So just to mention that.
Okay.
Then we have a question, how to get input data set structure based on specific DSD, such as national accounts. There is national accounts main aggregate data structure definition. Corresponding to it, how is the data set structure will be built? I think, Luca, you will be showing exactly that in the next presentation.
I think things may become clearer in the next presentation. And okay, if the next presentation still doesn't answer your question, please ask it again. I think we're going to see a bit of that now. Not with national accounts specifically, but more general use case.
And then finally, we have a question, the very final question: is there support for the Sdmx library of tools?
So in general, the support that you can find is depends a bit on the tool. So different tools are built by different organizations. The level to which these organizations support their own tools depends. It really depends on the organization and what their policy is, how many resources they have to do that. There are quite a few companies that exist now and give Sdmx consultancy services that are quite knowledgeable about the different tools, and therefore that can also provide support on different tools. I think what is still missing, I think Abdullah can support me on this, what I think we would need to invest more on as a community is better community support, right? I think there has been some attempts to build a community of users that can really be more interactive and provide support to each other when there are questions about specific applications, specific software. But this, I think, has been more difficult to get running. So in general, all the applications that I show that are listed have the support, some support. The level of support really depends on the organization that is publishing it or producing it or sustaining it. And there are definitely third-party companies that are able to provide also support as a service for the different applications shown. I've seen, for example, different companies that base part of their business model simply on providing support for some of Eurostat's applications, which is possible.
Yeah, thanks, Luca. Yes, I do. Basically, improving support for SDMX users is something on the roadmap of SDMX sponsors, and this is something we will be looking into it. All right, back to Luca.
Okay, so I'll just pass to the first quiz of the day. It's a short quiz, just on the on what we covered with this presentation. Give me just a second to open it. Just a second. Okay, so I'm not sure how many of you were in the follow the training yesterday, but we're going to use for this quiz the same software that we used yesterday. It's a software called Mentimeter. In order to participate in the quiz and give your answers, you have to go to www.menti.com and insert the code that you see at the top of your screen, 42399020. We're going to have 3 questions. You're going to have 80 seconds for each question. And we're going to go through them and explain a bit the results as we go along. So once again, if you want to participate in the quiz, take your phone, laptop, desktop, iPad, go to www.menti.com, use the code above, and you should be able to connect. If for whatever reason you're not able to connect in time, because you had some issues, because things were not working, don't worry, you can join at any time. The code at the top will remain, you can join at any time. And if you miss the first question, you can still join for the second and third. So I'll just give you still a few seconds to connect. I see we still have some users.
We have a question. What is the link for the quiz? The link is www.menti.com, and then you type the code, which is on the screen, 42399020. So please look at your screen.
Okay, I think the numbers are fairly stable. So we're going to start. Once again, if you haven't joined yet, you can join at any time, even if you missed the first question. Let's do it. So first question, what is the Sdmx registry used for? You have four options. To store administrative registers data, to store reference metadata, to store structural metadata, to register Sdmx users. We had a question that was quite similar to this. I think here, yeah, there is only one right answer, I would say. There is little room for interpretation. Okay. I think most of you voted. 10 seconds left for those of you who remain. There we go. 3, 2, 1. So a wide majority of you got the right answer, which is to store structural metadata. As was mentioned before, what we put in the registry is really the structural metadata for that describe the exchange or the transmission. So the DSD, the data flow, the constraints, the code list, the concept scheme. All of these objects are called structural metadata and are put in the registry. What could have been, what was maybe the tricky part in this question, and I saw that it caused some problems for some of you, is the difference between reference metadata and structural metadata, right? When we talk about the Sdmx objects, the Sdmx artifacts, the DSDs, the code list, we talk about structural metadata. It's the information, the objects that allow us to describe the structure of our data, the structure of our data exchange. When we talk about reference metadata in an Sdmx context, we're talking here about the textual metadata that accompanies the datasets. Sdmx stands for statistical data and metadata exchange. Sdmx can describe both data and reference metadata, right? Data is described via DSDs, data structure definitions, and reference metadata via MSDs, metadata structure definition. But the registry only stores the structural metadata, that is the DSDs and the MSDs. It doesn't contain the information itself, it doesn't contain the data itself, it doesn't contain the reference metadata itself. So I think the tricky part here was the difference between reference metadata and structural metadata. Okay, I think we can go on to the second question. You're all connected, so stay connected. If you disconnected, reconnect. Once again, www.menti.com, and always the same code. Let's go. Which are data retrieval methods in Sdmx? What are the different data exchange methods or architectures that we saw today? We have once again 4 options: get, put, and hub, push, pull, and hub, get, post, gather, search, browse, hit. I do expect a high rate of success here. Otherwise, I feel I will have failed as a trainer. So still 30 seconds. I see many of you already answered, which gives me hope that you all knew the answers straight away. All right, 10 seconds. Time's up. Yes, push, pull, and hub. I see this got the vast majority of responses. Indeed, in order to exchange data in Sdmx, we have three basic architectures. We have the push architecture, where you as data provider, you're sending the data to the data consumer. You have the pull architecture, where you as data consumer go and retrieve the data from the data provider using Sdmx web services. And then you have this hub architecture, where there is a central point that is connected to several Sdmx web services for several organizations, and that federates, sends out queries to different sources and federates the result. Yes, this was the right answer. Over 90% success rate. I feel I'm very happy about these results. Final question. Sdmx facilitates information. You have to complete the sentence. What does Sdmx facilitate? It facilitates information collection, dissemination, and reporting, exchange, archiving, and monitoring, replication, security, and backup, collection, exchange, evaluation. Once again, there is a single right answer, but there are a couple of red herrings, which may trip you up. Ten seconds left in case you're still undecided. Three, two, one. Let's see the results. Yes, indeed. So the correct answer is the one that most of you got, which is collection, dissemination, and reporting. The fourth answer is the one that was a bit trickier, in my opinion: collection, exchange, and evaluation. So I must say that, okay, it depends a bit on the meaning you give to evaluation. If that word instead of evaluation had been validation, then that answer would have been correct as well. Because Sdmx can also be used to validate data, as we will see in the next presentation. But evaluation is something more about really evaluating the data quality of a product or something, which just goes beyond what Sdmx can do. It's something broader. The correct answer was collection, dissemination, and reporting. Yes, and I think the only mean thing is that in the right answer we did not mention exchange, just to make it a bit tougher. So you're reporting data to someone, you're disseminating data to the wide world, or you're collecting data for someone. These are the basic scenarios for the use of Sdmx. And yeah, we tried to make it a bit more difficult, just to confuse you a bit by not putting exchange with what the obvious term in the right answer, and putting a term like evaluation in the fourth answer, which could lead to some doubts. But okay, overall, well, I think my quiz was easier than yours yesterday, Abdullah. I'm not sure if that's a good thing or a bad thing, but very good results overall.
Oh, we are getting progress as the capacity building session is going on.
You also have the leaderboard here. All of you are mentioned here, and probably many others got all the answers correct. So congratulations to all of you. And And yeah, well done. So this concludes our quiz. We're going to just take a break for a few minutes, and then we're going to go and look at the Sdmx converter.
Luca,
Please.
we have regards. We're behind the schedule. We were supposed to start this session 20 minutes ago, and we have a request from the hosts to finish in exactly 1 hour. So if we do have a break, I would appreciate if it was
5-minute break. We get back at so technical break, physiological break, back here at 5 to 6. 4 minutes.
In 4 minutes, 5 minutes to the hour. Thanks
5 minutes to the hour. Yeah, exactly. Yes, sorry, I gave it 5 minutes to the hour. So 5 to 6 in Central European time. If you're in Mexico, then it would be help me out, Abdullah. 5 to 11, I guess.
Okay. In Mexico, it's right now, yes, it's 5 to 11. In New York, it's 5 to 12. Thanks.
Good. So see you back here in a few minutes. Okay. So after this quick technical break, I think we can start coming back. Abdullah, you're still with us? Okay. Abdullah, if you're there, can you confirm that you see the presentation on the Sdmx converter? Ah, okay, I see you stepped away. All right.
Yes, Luca, I'm back. Did I miss something?
No. I just asked you if you were back. Okay, good.
Yeah, thanks.
So you can see the presentation, I guess, right, on the Sdmx converter.
Yes, the presentation is there.
Okay. So I'm going to talk about the Sdmx converter, the Eurosol Sdmx converter, which is one of the tools that you can use to convert data from one format to another, from one non-Sdmx format to an Sdmx format. It is one example of what in the previous presentation I called the format converter type of tools. I'm going to go quite fast because I think you've had a sufficient introduction to the Sdmx standard. I'm going to present a bit the tool, and then we're going to do a demo, and finally have a little quiz. Once again, I'm not trying to encourage necessarily users to use this tool or trying to market it. I don't get any commission with the number of users of the Sdmx converter. It's just a tool that is really good for entry-level users to get accustomed to Sdmx, to get a feeling for how Sdmx works. So let's talk a bit about the tool itself. So often, as we discussed, one issue that you have when you first need to send to someone some Sdmx compliant data is that your data is in different formats that are not Sdmx compliant. You have some CSV formats, which is the first example here at the top. You have some fixed length record format, which would be the second example here. You have some Excel, right? And you want to convert this into whatever format you are required or requested to provide to someone who's asked you to send Sdmx data. This could be Sdmxml, it could be Sdmx CSV. And Sdmxml itself, as a format, has several different flavors available. So what the Sdmx converter does is exactly this. It takes a file in an existing format and allows you to transform it to convert it into an Sdmx compliant format. It also allows you to do the opposite. You can also take an Sdmx compliant format and transform it back to a non-Sdmx compliant format. But the major use case is usually to go from Sdmx from a non-SDMX format to an SDMX format. So unsurprisingly, the converter, given the name, does conversion, but it also does another thing, which is very useful, and which is also why it makes it a good learning tool. It also validates the data. It allows you to check whether the data is that you provided is correct according to the DSD. So basically, when you feed to it a data set and a DSD, the converter allows you to check that you're using the right concepts, that you're using the right codes, and returns errors if you're not. So it does conversion, it does validation, and it can do both together. It can convert files, it can validate files, and it can convert and validate files at the same time. Those are the three main operations that the converter does. How is it made available? So the converter is available in different flavors. It's always the same software, just available in different flavors, different, I think flavor is the right word. We have the converter available as a web application with an interactive graphical user interface. This is what we're going to use today. We're going to use the web application. You also have the converter available as a desktop application that can be downloaded and on your PC, still with a graphical user interface. To be honest, in the future, Eurostat will focus more resources on the web application, and probably at some point the desktop application will be discontinued. And today we're going to look at the web application. But the web application or desktop application are really for manual setup, manual conversions. There's also flavors of the converter that are available for more batch processing or automated processing. So the converter is available as a command line tool that you can download and on your own infrastructure, on your own PC, which can be used to automate certain conversion jobs. It's also available as a web service, actually two different web services, one for conversion and one for validation, that you can also use to automate conversion and validation jobs. And it's also available as a Java library, which you can integrate into whatever program you may want to build using Java. So those are the different flavors. Each flavor is better for a different use. So once again, if you want to do something manually, go for the web application. If you want to do something automated, the command line tool or the web service is the way to go. How does the converter basically work? And you're going to see this in action in a few minutes. Whatever you want to do, you always need to have an input data file, and you need to have a data structure definition or a data flow. Those are the two main elements that you have to supply in any case. You have to have your input data file, usually a non-SDMX data file, and you have your data structure definition, your data flow that defines the SDMX structure that you want to use to convert or to validate this file. Those are the common parameters. And then for different conversion jobs, you have different specific parameters that may need to be provided. For example, if you want to convert to or from CSV, there are some specific CSV parameters that would need to be provided. If you want to convert to SDMXML, you're going to need to provide most likely as a parameter the SDMXML header that you should apply. And for other formats and other combinations of input and output formats, you may have other parameters that need to be supplied. So in general, you always have to provide the input file, always have to provide a DSD or a data flow, but you can also, and then depending on the specific transformation, you have other parameters to provide. This is just an example here. And we're going to see it, in a few minutes with the live with a specific example. In general, when you look at the converter web app, you see these three items in the navigation menu: the input, where you put your input file; the structure, where you put the DSD or data flow, and the result of the conversion or validation. But depending on the parameters that you use, so if, for example, if your input is a CSV, you're going to have an additional screen that asks you to provide also the necessary CSV input details. If you want to give a specific mapping for the CSV or specific transcoding, what exactly this is, we'll see in a second. Once again, you're going to have additional specific screens come up and to ask you to provide that information. So the basic is the input and the structure, and then depending on your configurations, you'll have different screens pop up for providing the different additional parameters. So we're going to use the web app as for the demo. And the web app is an application that we make available on the web. It's actually available to anyone who has an EU login account. So EU login is, let's say, the authentication mechanism that is used for all European Commission web services on the web. So you don't need to have specific access rights. As long as you have an EU login account, you can use the converter. And obviously, it's free to create an EU login account. I'm not going to show you how to create an EU login account. We have available online an explanatory video that explains to you how to create an account. But in general, it's quite easy. And once you have that account, you can use our Sdmx converter online. So basically, what is the message? If you're new to Sdmx, you want to explore the converter, or you just want to learn a bit more about Sdmx, feel free to use the converter web app that we make available. You can use it. Just make sure that you create an EU login account first so you can access it. And we have some explanatory information on how to do that available on the web. So before I start the demo, are there any basic questions that I should address? I don't see any in the Q&A, so I'm assuming that I can move on. Let's go. We're going to do a demo, and for the demo, I'm going to focus on the following three use cases. I'm going to show you how to convert from CSV to Sdmx structure specific. Then do the opposite, from Sdmx structure specific to CSV. And then I'm going to show you how to convert also from Excel to Sdmx generic. This is a demo. In case you miss anything, okay, you're going to have the recording of this event to look at, but we also have some exercises available online for you to look at and to try your hand with. Okay, so let's go to the presentation, to the converter itself. There we go. You should see right now the converter web application. The link to the web application is available on the presentation. And once again, you only need to have an EU login account to be able to access. So the first thing you see is that we're in the input screen, and we're asked what operation we want to perform, and what files we want to convert. Before we actually supply a file for conversion, I want to show you a bit what kind of conversion we're going to try to do at first. So we're going to try to convert these CSV files, actually, these three, into an Sdmxml structure specific file. I'm going to open one of the files. Actually, I'm going to open it via Notepad. I think it's going to be easier. So this is a very simple CSV file. It has a header with names of concepts, and it has.
Luca,
please,
if you can, please increase the scale because.
Yes, good point. This should be better, right?
Yep, much better.
Okay. So you have a series of concepts and you have a series of columns. It's a semicolon separated CSV. And it contains data about population. It's population data. Obviously, it's fake data, but that doesn't really matter. The first column is the frequency. The second column is the country, in this case, Latvia. The third is the year, the time period. The fourth is the indicator. Then you have a bunch of attributes, and then you have the observation value. We also have a couple more examples of this same data set, which are just slight variations with two slight issues. So in this first variation, you have, instead of code A for the frequency, you have one observation where we have a code C. And in this second variation, you have, for the observation value, for the last observation, one of the observation value is equal to Sdmx. And in order to perform the conversion, we're going to use this DSD, which I'm going to show. And I think this actually is the first time in this course that you actually see a DSD. I think maybe yesterday with Abdullah, you saw some screenshots maybe of the XML, but this is actually what a DSD looks like. It looks like a set of XML tags, which contain all the data flows, contain all the code lists, contain all the concepts. And then in the DSD, you have the list of dimensions, the list of attributes, and the primary measure. So this is what a DSD looks like. All the information that Abdullah explained yesterday about the dimensions, about the attributes, it's all contained and codified in this XML file. Before we start, I just want to make a couple of points about this DSD. This DSD has a small number of dimensions. So we have only 4 dimensions: frequency, geo, which is the reference area, the indicator, basically, which is called deb here as a dimension. And then we have a time dimension, which is the time period. We have a series of attributes. We have one confidentiality status. We have the unit, decimals, several observation statuses, actually, and one attribute for comments. All of these attributes are conditional, which means that they're not mandatory. And then we have the measure, which is the observation value. Couple of points before we start. The observation value is specified that it has to be an integer. You remember yesterday, Abdullah talked about representations, and each concept in Sdmx has a representation. This representation is visible in the DSD. And here, for example, for the observation value, you see that the representation is an integer. We expect an integer with a minimum value of 1. And for frequency, the representation is a code list. So we expect here codes that come from a code list. The code list here is CLFREC, which is a standard Sdmx code list, which is also available in the DSD. I'm just going to find it. And you see it here. This is the CLFREC code list. So we're going to use a DSD, which has 4 dimensions, a bunch of conditional, optional attributes, basically, and one observation measure, the one observation value. The observation value is supposed to be an integer, and the dimensions, and especially the frequency, is supposed to be represented by a code list, and the code list is available in the DSD file. Okay, that's just for the introduction. This will come in handy later. Please, Abdul.
Yeah, just a quick comment. So what you are seeing now is the actual Sdmx data structure definition. I mean, typically you don't have to inspect the file using an editor such as Notepad. You don't have to read the source row XML, and you have a variety of tools that help you construct the data structure definition. However, since it's XML, which is text-based, you can read the file directly if you can understand this, and it sometimes can be useful. But typically, you don't have to parse it yourself. You have software that does it for you. Thanks, Luke.
That's a good point, Abdullah. I don't want to scare our colleagues. I could have shown the same DSD in our registry, where you would have seen much more easily what are the codes available and all of this in a much more user-friendly manner. But I thought it would be useful to at least introduce a bit how the SDMXML syntax looks like.
It's very useful, Luca, because very often you need to see the actual structure to understand this is what you are creating, because when you're working with the software, sometimes, I mean, it's useful to see the actual data set and the actual XML, but most of the time you don't have to read it. You have software that helps you do that. Back to you. Okay,
so we want to convert the first Excel file I showed you into, which is the first CSV file I showed you, which is a CSV file. We want to convert it into SDMXML structure specific. So I load here the CSV file. I can select the maximum average I want displayed. I can keep it to 100. It doesn't really matter. It already understood that the input format is CSV. And then I want to put as output structure specific 2.1. And I need to give a file name. I will call it Sdmx Global Conference 2021 1. I gave my input. Next step, I need to give the structure. And you see that already in the navigation, it saw, oh, okay, I have an input the CSV file. I will need to create another menu in the navigation to get the input details for the CSV file. But before that, we need to give the structure. And here we have two options to give the structure. We can either import the DSD. So first of all, I need to specify whether I'm using a DSD or a data flow. In this case, I will be using a DSD for the conversion. And then I need to either import the file itself, the XML file that I showed you, or if the file is available in the registry, I can just connect to the registry. For this use case, I'm going to use the second option. I'm going to connect to a registry. So I will say use registry. And then here I have a list of registry web service addresses that are available, that are already configured. If the registry of your choice is not here, you can just select other and then put here the address of the web service of the registry that you want to use. But in my case, I want to use our Sdmx registry, the one we have in Eurostat, and this is obviously already configured here. I can just select it. I can query the registry, and I will get returned the list of structures that exist, the list of DSDs that exist in this registry. Now, in this case, I know which DSD I want to use. It's the one that was mentioned. It's called stat-dem demobile 1.0. So I'm just going to select the structure here, stat as the agency, then demobile as the artifact ID, version 1.0. There you go. I retrieved the DSD from the registry, and I told my converter what DSD I want to use. Then I go next. Here we have a few parameters that we need to provide. First of all, they ask us about the header configuration. This header configuration has to do with the header of the SDMXML file. This is something Abdullah mentioned yesterday, but maybe you don't remember. In the SDMXML files, you have always a message, so the data itself, But before you get the data, you have a header in the file that specifies who is sending the data, when the data was sent, the contact point for issues. You can specify all of these things in the header. The header is mandatory and certain elements of the header are mandatory. So we will just configure the header manually in this case. And then I'm asked to provide the CSV input parameters. Here, I need to tell the converter how to read the CSV file. The converter doesn't know what it's supposed to do with the CSV file. So it's asking me, first of all, the delimiter. And you saw before that we're using semicolon as a delimiter. And the second important thing that it's asking me is about the header row. So here, the converter wants to know, okay, I'm going to need to map each column, each field of the CSV. I'm going to need to map it to a concept in the DSD. And there's two basic ways the Sdmx converter can do that. It can either do the mapping based on the header of the CSV file, in which case the converter will read the header and will say, and will try to map the CSV based on the IDs put in the header. So here it will say, okay, well, I'm going to say that the first column is called FREC in the CSV. I'm going to look in the DSD if there is a concept called FREC, and I'm going to map this column to the concept FREC. And this works very well as long as your file has a header that matches, where the names of the columns match the names of the concepts in the DSD, which is our case. But in case that's not possible, in case your CSV file does not contain this information, it does not have in the header the name of the concept IDs that you find in the DSD, then you can map manually each column in the CSV to a specific concept in the DSD. Now, in this case, we're lucky. I mean, we're lucky, not really, because we designed the demo this way, but we designed in a way that, as you can see, the header of the input CSV, the elements in the header already match the concept IDs in the DSD. And so I can just tell the converter to use the header for the converter, to know how to match the columns, in the CSV to the DSD concepts based on the values in the header. And this actually answers the question we received before. If I need to create a CSV file that can be easily transformed into SDMXML, this is what I would do. I would create a CSV file that has in the header the same concept IDs that I have in the DSD. That makes the conversion easier to configure. Anyway, this is set. Before I can finalize, as I mentioned, we need to create the SDMX header, the header of the SDMXML file. There are three fields which are mandatory: the ID of the data set, the time at which it was prepared, and the ID of the sender. All the other fields are possible, but they're optional. Okay, here I just changed the ID from the default that we have, but all the mandatory header elements are here, so I can click next. I give the converter some time to think. And there you go. It tells me it did the conversion. It didn't find any validation errors. And I can download the result. And the result is a beautiful SDMXML file. Once again, as Abdullah mentioned, usually you don't need to interact with the file itself, but I just want to show you what it looks like. So you see that for each row in the CSV, the converter created an observation, which contains the information that existed in the CSV. it also created a header here with the information I put in the manually put for the header. So we have the ID, we have the prepared date, we have the sender, and we have the information about which DSD was used. Okay, that's a very basic use case and the simplest way probably that you can do this. You had a nice file at the beginning, it was already perfect. You had already the header that was easily mapped, that had the concept, that used the concept IDs in the DSD. You just select your input, you select your DSD, you click a couple of times, and you have your Sdmx file. Let's try something a bit different. And instead of putting this file here, I'm going to put the two other files I showed you. And these two other files are exactly the same, except that one has a C, code C in the frequency column for one of the observations, and the second one has Sdmx as one of the observation values. So for the rest, I keep the configuration the same. I'm using the same DSD as before. I'm using the same CSV input configurations as before. I'm using the same Sdmx header as before. And then I'm trying to convert. What do you think will happen here? Let's give it once again a couple of times to think. So in this case, for both data sets, it found an issue. It tells me it found a validation error. Why did it find a validation error? Well, because in both cases that I uploaded, there was an issue. The input data did not conform to the DSD. We had, for example, in the first data set, the dimension frequency, FREC, was reporting value C. But in the frequency DSD, in the frequency code list, there is no value C. It's not allowed. It doesn't exist. So what the converter is telling me is, look, you're using a value that doesn't exist in the code list. This is wrong. And likewise, for the second file that had as one of the observation value, the value Sdmx, the converter is telling me, look, this is not possible. The observation value in the DSD is set to be an integer. And here you're giving me some sort of string. That doesn't work. I cannot accept it. It's an error. It gives you the type of error. It gives you also the location of the error. Now, one thing that you should know is that in many cases, in most cases, the converter will still give you an output. It will still give you a converted result, an Sdmx file, even if there are validation errors. But obviously, if you have validation errors, you should correct something and not just use the output that the converter gives you. The converter is nice. It still says, okay, well, you got a bunch of errors in your file, but here's an Sdmx file anyway. But of course, if there are validation errors, you should do something about it. Now, I want to get here to one small point before I go to the next use case. Let's work on the first one, the first data set that had an issue in the frequency dimension. And you might say, okay, but this is the file that I get. Your file that you get from your database happens to have this code C, because in your database, code C stands for angle. And that's how you got the data. It has code C instead of A for this dimension. That's how it is. You cannot change this. But you still want to be Sdmx compliant. So what can you do in the converter to confront these situations? Once again, we have our data set here. we still use the same structure. But then when I go to my CSV parameterization, I say that I want to transcode some fields. This is something the converter can do. If your input file is using some fields, some codes that do not exist in the DSD, you can transcode them in the converter. So the converter allows you to do some basic mapping, some basic transcoding, not at a level of sophistication as you would have in something like a mapping system or the meta manager by ESTAT, but yeah, some simple transcoding, simple mappings you can do. I'm just going to show you how to set up a transcoding. So very quickly here, I said that I wanted transcoding, and so I had a new screen appear about CSV input transcoding. And here I say that for concept frac, value C should be mapped to value, let's say A. I say add transcoding, then next. And what will magically happen here? Well, not magic, but almost. All of a sudden, the converter says your data is correct. It corresponds to the DSD. Why? Because I took the issue, the C flag, the C code for frequency, and I changed it. I turned it into an A code, which is allowed. And in the result, I will have frequency that is A for all observations, because I did the transcoding. So this is just a basic use case for how we can take a CSV input file and turn it into Sdmxml. And in some cases, in the middle, also do some transcoding, some mapping, so that if the CSV file structure doesn't really correspond to the DSD, in the converter, you can switch things around and make it correspond to the DSD, using the transcoding possibility, using the mapping possibilities. Once again, it's not as sophisticated as something as mapping system, but it's something that works in most cases. Now, in the interest of time, and for the next example, I will not do a conversion from Sdmxml to Sdmx to CSV. We have examples on our website about how to do that. But I will do a quick view of how it works for Excel, because this is a very common use case. It's a bit more complicated because it needs something to be configured, but it's something very common for users to only have data in Excel and not even in CSV. So here we take an Excel file. I'm just going to try to take an Excel file. There we go. And what do we have in this Excel file? So we have some data here. We have some data about pesticides, something I know absolutely nothing about, which doesn't stop me from talking about it. So, and you have for different pesticides, you have pesticide codes here. And for each pesticide, you have the number or the quantity of pesticides put on the market. You have the value, you have a flag for confidentiality status, you have a flag for observation status. And we have a DSD for this data set, which is likewise quite simple. I will just show it quickly. You have, in the DSD, you have a few dimensions: the frequency, the country, the pesticide, and the time. You have a few attributes: the observation status and the confidentiality status, and you have the observation value. So very simple DSD, 4 dimensions, 2 attributes, 1 observation value. And what we can do with the converter is we can put a parameter sheet, which basically takes all the concepts that we have in the DSD, all the dimensions and the attributes, sorry, that we have in the DSD, the 4 dimensions and 2 attributes, and it tells the converter where it can find the information. So it tells, for example, here, I'm not going to go into the details, but you can get the gist of it. The country code, where can it be found? In cell B2. There it is. That's where you find your country code. What about the time period? Where can it be found? In cell B3. This is where you find your time period. What about the pesticide code? Where can I find it? It's in column 4. Yes, indeed. It's in this column. Column 4, I find the pesticide code. And then I tell the converter, this is where you find your data. You find your data starting from cell E8 in one column. And yeah, you read the whole column, basically. It's in cell E8, it's in a single column, go down. Right? So these kind of parameterizations are not part of the Sdmx standard. This is specific to the Sdmx converter, and other tools that do conversion from Excel will have different parameters and different way of setting it up. But this is how it's done in the converter, and it's quite flexible. You can handle a lot of use cases. You just need to understand a bit how to parameterize it. So we can try it. We have our Excel file, which I will try to upload. The converter understands Excel. I still want to transform it to Sdmx structure specific. I will take the DSD. This time I will not take it from the registry. I could, but I decided to just upload it, just to show you how to do it. There we go. Oops, small. Excel input details. So once again, here I need to put the header configuration for the Sdmxml file. In the Excel file itself, you have this parameter sheet that contains the parameters. So you don't actually need to put any additional parameterization. But you could decide to externalize the parameter file and to use an external parameter sheet instead of the one that is in the file itself. In this case, it's not needed because the parameter sheet is in the file itself. So we can ignore this. We don't need to have any additional configuration, additional parameters. We click on next. You would ask for confirmation of the Sdmxml header. I say next. And once again, magically, it will tell me the data is valid. There were no issues with codes or with formats. And out of this Excel, I have created a nice Sdmxml file with the 700 and something observations which existed in the Excel file. So it is definitely possible to convert it from Excel as well. It takes a bit more work to configure the parameterization, and you may need to adapt your input Excel file in case it cannot be handled by the parameterization possibilities. But once you've done it, you can see the process is in the end quite simple. So I'm going to finish the demo now and go back to the presentation. And before I leave you to the quiz, I want to, okay, you have the link here to the converter. You will have the recording about all of this, so you can repeat the steps. But I want to point you to our website here, this link here, because here you will find basically all the information you need to have to get started with the converter. You have, this is the wiki space we use currently to give information about the tools that we use and the Sdmx tools and standards that we use. And you have a page about the converter. It gives you some information about the tool itself, the kind of conversions it can handle, the kind of input and outputs it can handle. There's a link to a user guide, which is quite useful and covers the main conversion use cases, including the ones we did today. You have some videos as well, and you can use the videos also as exercises. So we have 4 conversion use cases with a video explaining to you how you need to do them, with the input data, all the data you need to set them up. So you can try to do them yourself, and then if you don't manage, look at the video, or the other way around, look at the video and try to replicate. And we also have links to the tools themselves if you want to download them, if you don't want to use our web app or you want to download the tool. And it has links to the training courses and the webinars that we do for the converter. We do regular webinars for the converter, and you can find on the same website on our training calendar when the next webinar would be. And it's open also for users outside of the EU. Even though yours that we work for the EU, our webinars are available to anyone who is able to register. So yeah, that's pretty much it. And I wonder if we have any questions, which I will take and then go directly to the quiz.
Yes, Luca, we do have some questions. The first, does the order of the CSV header fields have to be in any particular order?
That's a good question. The answer is no, Vilas. You can put them in any order. In case the CSV has the header of the CSV uses the concept IDs of the DSD, then okay, you can put them in any order, and the converter will understand what column corresponds to which concept by looking at the header. If the header doesn't correspond to the concept IDs, then you can just in the CSV input details screen, you can manually map each here, custom field mapping, custom column to concept mapping. You will be able to manually map each DSD concept to each Sdmx CSV column, basically. So the order is really not important. You can set it however you want. So basically, that's pretty much it. Here I'm saying that, yeah. Then.
Thanks, Luca. Next question. Why use transcoder instead of fixing the CSV file?
That depends. I mean, I would be more than happy to fix the CSV file. It depends really on your use case. Sometimes you take your data out of a database, and the database just happens to create that data set. It's difficult to change the source or whatever process creates that CSV, or simply you're annoyed and that process is managed by someone else, and you just want to get a valid CSV file. In that case, you can do the transcoding here. In general, minimizing the amount of transcoding and applying whatever transcoding as much closer to the source as possible, rather than at the end, is the way to go. But there may be reasons why this cannot be done. Usually, it's not technical reasons and just process organizational reasons.
Yeah, if you allow me just to quickly add, if all you have to do is take a single Excel file or CSV file and convert it, then it doesn't make a difference. However, imagine that you have recurring CSV or Excel files, like you receive them every week or every month, and you have no control over their format. In that case, transcoding saves you a ton of time, because instead of doing it for every spreadsheet or file, you can just save your transcodings and then reuse them each time. The next question, actually, I skipped it. It was supposed to be before. Does Sdmx Converter allow conversion of multiple DSDs in one single input CSV file?
No, it doesn't, and there's a good reason. Each data set in Sdmx is described by one DSD. It is not possible, let's say, or it doesn't make sense to say one data set has multiple DSDs. So if you have one data set, you have one DSD. That's basically it. Each data set must have one structure, which then corresponds to one DSD. You can definitely, if you can still try, if you have different data sets and you want to convert them to a CSV file that looks similar, I mean, you can try to do that, I guess, with some mapping and transcoding, but in general, it's one data set, one DSD.
I think that actually it is possible I mean, you definitely cannot transform a CSV file into with multiple DSDs in one go. However, you can, in principle, map the same file to different DSDs and then run the conversion several times and produce XML structures. I mean, Sdmx structure, Sdmx data sets in according with different DSDs. But you cannot do that in one go. You'd have to map them separately and transform them separately, right, Luca?
Yes. In that case, yes.
Yeah.
But I'd say, yeah, whatever output will be described by a single DSD. Whatever you do.
Okay.
Yeah.
Next question. If there are multiple sheets in an Excel file, each sheet name being a country name or code, how can that be parameterized?
Yeah. So that's a good question. In the Excel, the Sdmx converter, at least our converter, cannot take parameters from the sheet name. So it's much better to have the parameters in the sheet itself. So maybe you can have an Excel function to extract the information from the sheet name and put it in a specific cell in each sheet. You could theoretically try to have one parameter sheet for each sheet, data sheet, and for each parameter sheet kind of hard code what is the country specified by that, including that sheet, but that seems very hard coded. So in general, the converter does not take parameters from the sheet name. It needs to take them from the from inside the sheet. And I would advise to find a way to get the file like that, to look like that. Okay.
Yeah, thanks. You can just place the country code in the sheet. Okay, it's automated if you can. If not, just manually, you can manually add the country code to each sheet and map into the same cell on each sheet, the same address, and then you can map that and output this. If you can do that, then it's possible. And then we have more questions.
I can do a quick fire round before we go to the quiz because I'm very mindful of the time.
Yes.
So, is it mandatory to use a parameter file? If you're using Excel as an input, yes, it is mandatory. You need to have a parameter file, and the parameter file must look the way that the converter expects it to look. And we have explanations on our website that I showed about how to build such a parameter file. But for Excel, it is mandatory. What is the difference between this converter and the Java version conversion that is issued by Eurostat? It is, I guess that by the Java version, you mean the desktop version. It is the same converter. It is the same libraries that are being used. It's just a different package. The web app is a web application. The Java version is a desktop version that is installed on your own PC, but the functionalities and the libraries you use for the conversion of validation are exactly the same. As I mentioned, however, we want to invest more in the web app and less in the desktop in the future. Is it possible to merge files in Sdmx? Theoretically, yes, but not with the converter. The converter here is one input file in, one input file out. If I have three CSVs, even if I would like to merge them in the same Sdmxml file, I will not be able to do that with the converter. But in theory, and with something like the mapping assistant, you could map different tables of a given database to the same Sdmxml output. But with the converter, as I mentioned, it's a simple tool, one file in, one file out. There was two questions about the national data summary pages, which I cannot answer because this is something specific to the IMF, I believe. I'm not sure if we have any IMF colleagues in the call that could specify this. I'm not familiar with the collection process for the national summary data pages that are used by the IMF, I believe, in the SDDS transmission. I'm not sure if you know more about this, Abdullah. It's not a process I'm familiar with.
No, I cannot answer that question either. I'm sure that the IMF can.
I would suggest Soborun to contact whatever contact point you have at the IMF. If you have trouble, you can contact me directly. I will try to find out for you if we can have this, if we can find this out for you. And then we have a question which I will gladly leave to David tomorrow about how to represent geospatial data in Sdmx. I think this goes beyond the scope of this presentation today. It's a very interesting question. It's a question that received a lot of attention during the development of Sdmx 3.0. I would suggest you ask it tomorrow, where you're going to have David, who is going to talk a bit more about modeling, best practice for modeling, and we'll be able to address this question on geospatial data. All right, quick fire round. Got rid of all the questions, I hope in a fast but satisfactory manner. I don't want to rob you of your quiz. We have a few minutes left, so I want all of you to have the possibility to take the Sdmx converter quiz. So give me a second and I will get it up on the screen for you. Okay, so we have there we go. You know the drill by now. You want to participate in the quiz, it's www.menti.com. And this time the code has changed. You have to input a new code, 6220-9572. It's a different quiz than before. Therefore, it is a different code. You have 3 questions in this quiz. It's all about the converter. And I expect great results from all of you. I will hold you all to a very high standard. By the way, Abdullah, can you, maybe you know, can you choose your avatar when you connect to Mentimeter? I never really tried.
I haven't connected for this particular one. I haven't connected as a participant, and the last time I did use it, I think there were no avatars yet.
Beautiful avatars. I'm surprised there are so many, actually. Okay. Once again, if you're not able to connect immediately, you can connect at any point in time during the quiz. And we'll start it right now. Okay, first question. What can the Sdmx converter do? You have we have, for whatever reason, 48 seconds for this question. It can convert data files to, from, and between Sdmx formats. It verifies that the structure of a data file matches an Sdmx MSD. It executes content validation rules on data files. This one can be tricky. There is one right answer, but the wording is very important. Pay attention to the details. Very good. Actually, this is really good. Congratulations to you all. Indeed, the converter can convert data files to, from, and between Sdmx formats. The reason why the second answer was wrong is because it mentioned MSD. And the converter does not work with MSDs, which are metadata structure definitions. It works with DSDs, data structure definitions. So it works for the data, but not for the reference metadata. I think quite a few people would have been happy if we worked with the reference metadata as well, but it doesn't. So that's why the second answer was wrong. And the third answer was wrong because it was talking about content validation rules. Now, indeed, the converter does validate the file, but it validates only the structure of the file. It validates the file against the structure defined in the DSD. So it executes structure validation rules. When we talk about content validation rules, we talk about rules like, the sum of the observations is equal to the total, to the expected total. And this is not, this kind of algebraic or arithmetic validations is not something the Sdmx converter can do. It can simply validate the structure. It was a tricky wording, but you all did very well.
Just a quick comment, Luca. Yes, support for content validation in terms of algebraic validation, mathematical aggregates, outliers. This will be introduced in VTL, and it's not supported in Sdmx converter. However, content constraints are supported in Sdmx converter. So there are some simple validation rules, like those which I mentioned before yesterday. If your indicator is surface area, then you cannot have sex male. That type of validation, content constraints you can use with Sdmx converter. And I look forward to when Sdmx converter supports VTL for even more robust validation. Back to you, Luca.
You can look forward to it, yes. So, question 2. Do I need to install the converter locally in order to use it? 3 possibilities. Yes, the converter is only available for local installation. Second possibility, no, but local installation is preferred. Third possibility, no, there's options that require no installation. Converter web app. Here, I guess you could have a bit of a discussion around the different possibilities, but let's see what our colleagues answer. So we already have 46 responses, 47. There were about 50 people connected, so almost everyone responded. If you're among the few that didn't, you still have 3 seconds. Time's up. Let's see the answers. Very good. So indeed, we do have the web app, which is available online. The only requirement to use it is for you to have an EU login account, which is a bit of a barrier, but can be freely made by anyone. You also have flavors that are installed locally, which is fine, and definitely for some applications, you need to install it locally, because if you want to have a production system, you cannot rely on our manual web app. That's clear. So that's why there's a debate on whether the second answer would be correct. Could be correct, because in certain use cases, depending on your use case, yeah, you will need to install it locally. But in general, if you just want to do a quick conversion, if you just want to play around, I think it's much easier to use the web app. And it's easier for you and probably easier for us as well when we need to provide some support, because we're more in control about of the infrastructure. So the third answer is definitely correct. The local installation is possible, and definitely in certain use cases is something that would probably be preferred. So if you're in one of those use cases, probably if you answered with the second option, it was not really incorrect. Last question, everyone. What are the minimum input elements required by the Sdmx converter? Minimum input elements. 3 options: a suitable DSD and data flow, a suitable DSD data flow and an input data file, an input data file, a suitable DSD data flow, and CSV parameters. This is really about the minimum requirements that are needed for any conversion. Still 5 seconds left. Yes, I see the latecomers are deciding. Time's up. 51 answers. And indeed, the central one is the correct one. So whatever the conversion you want to do or the validation, you will always need an input data file because you need to validate or convert something, and you will need a DSD. All the other parameters, whether it's CSV parameters, Excel parameters, fixed length record parameters, SDMXML parameters, depend on the specific input and output formats that you choose. In most cases, you will need to provide some additional parameters, but the minimum input elements required for any kind of conversion that you need for any conversion are the DSD and the input data file. Probably most of you had CSV conversion in mind, and indeed, if you have a CSV conversion, you will need to provide also the CSV parameters as specified in the third option. But there are definitely some conversions that do not require additional parameters at all, especially conversions between SDMX formats. For those, usually the DSD and the input data file are sufficient.
Yes, I would have answered, I would have given the answer number 3, so you can count me among the 17 or add me and make me 18. Because almost always you need parameters, yeah, but not always, yeah, that is true.
It is true that like 90% of the conversions we do are either with CSV parameters or Excel parameters, so I can definitely understand the tendency to go for 3. But we are strict and we apply the letter of the law. Okay, if you all want to see your results, I think we're gonna have a bunch of winners. There you go. I'm sure there's other of you who also were among the leaders here and not just the 10 colleagues displayed. But bravo to all of you. You achieved once again 100% success ratio. Okay. That's the end of my presentation for today. I don't see additional questions. I therefore would like to thank you all for the attention today and invite you all to connect again tomorrow, where David will talk about best practices for DSD modelers. And you will see me again talking about SDMX, REST, APIs, and web services. That's it from my side. Abdullah, final words from you?
No, thanks very much, Luca, and thanks to the participants who have stayed until the end, despite all the time zone differences. And I know that it's late at night in many places where our participants live. So thanks very much for staying on. I think we have a quick announcement regarding geospatial information. There will be an in-depth description of and discussion of geospatial on the first day of the conference on Monday, and it will be given by Juan Munoz. Back to you, Luca.
Yes, indeed. Thank you, Abdullah, for mentioning that this information that came from David Baraclaw in the chat. Yes, the support for geospatial information will be a key point discussed during the conference. So thank you all again for your time. In case we were not able to answer your questions today, there is always tomorrow, well, you can also reach us later via email for any other topics. So thank you. Thank you also to our ENG organizers for the support, and we'll see each other tomorrow as well.
Right. Thank you very much, Luca. Thank you very much, Abdullah, and everybody, all the participants. We appreciate your participation here. See you tomorrow and have a wonderful afternoon or noon. Depends where you are. See you.
Thanks very much, everyone, and have a good day or night, depending on where you are in the world.